Hello, everyone, and good afternoon, good evening, or good morning, depending on where you're from. Thank you so much for being here today. Um, Before I begin, the first thing that I should do is make sure that people can hear me and they can see me. Now, I can see myself, but I'm hoping that people can hear me. So I see a lot of people here in the comment section. So thank you so much for the comments. By all means, while we're waiting here, just a few minutes or another a minute, I think I'll give people. Just please go ahead and let me know where are you from, or what city, what country, and this would be great to see. I can already see there's a whole bunch of people from all over the place, which is fantastic. So welcome, welcome. Like I said, I'm just going to give people just another 30 seconds or so to get here, and then we'll get going here. So yeah, just stand by. I'm going to set up some things here for the presentation, make sure everything is working. It appears it is, which is good here on my end. And we'll get started talking about iPhone Lidar. Okay, well, I think that's good. It's 2:02. I like to start on time. And again, I want to welcome everybody, people who just joined us and just popped in. So today, I have the pleasure of introducing you to Recon-3D, which is an app, an iPhone app that I've been developing with a small team of people who have been fantastic. And I am going to present to you some information about iPhone LiDAR and a number of different things. So let me get to it. Let me put up the, let me share my screen here. And I'm hoping everybody should be able to see the presentation here, and I'm going to get going. So I'm going to do just a very brief introduction. For those of you wondering how long this is going to take, I'm not entirely sure. I don't like to rush. I don't want to rush today, so I'm just going to take my time. And I've got a number of different things that are planned. So we will see how that goes. I'm just going to let it go. This is going to be, there were a number of people who emailed me and said, hey, I can't make it, or I'm tied up for half of it or something like that. So once we do finish this thing, it's going to be available on YouTube. Okay, so it's not going to be pulled off or anything. It will be available for some time yet. So if you have any friends or any colleagues that want to watch this afterwards, they definitely can. So make sure that they know about it. And I believe it's the same link, so you can just use the same link and you should be able to get to it on YouTube. Okay, well, let's get going here. And first thing, let me make sure. All right. Well, just a very brief introduction here about myself. And so, so my name is Eugene Lisho, and I am a professional engineer in the province of Ontario, Canada. And originally, I started off in the aerospace industry. I studied aerospace engineering, and I worked in the industry for a while before making a career change. And then in 2005, I had an interest in the area of forensics and using 3D technologies and applying them to different aspects of forensics. So initially, it had to do, with like collisions and vehicle reconstruction, but slowly and over time, and just through the people that I met, it evolved into something else, which was mostly on the crime side. So a lot of the work that I do surrounds like homicide cases, shooting reconstructions, bloodstain patterns, and things like that. So that's really cool. I'm an adjunct professor at the University of Toronto in Mississauga, and I started there about 2013 is when I believe I started the first course there. And through some of the people who I met, I think I proposed a class and the timing was just right and it just happened. So I teach a course that's called 3D Forensic Mapping and Reconstruction. And the purpose of the course is to use 3D technologies to solve problems in forensics. And sort of in three areas. So one is for the documentation. So a documentation of a crime scene. What are some of the challenges there and things like that, which is what we're going to be talking about today. Then there's also the analysis. So now that you have this data, what kinds of things can you do with the data? So are you doing collision reconstruction? Are you doing a shooting reconstruction or whatever it might be? And then finally, there's the analysis, or excuse me, the visualization. So you have this data, how you present it and that sort of thing. So one of the benefits of being at the university is that there's a lot of students. So this was a busy year for me, and I had 7 internship students this year. working in different areas, shooting reconstruction, structured light scanners for footwear impressions, just photogrammetry related stuff. We did some work on using tasers and things like that. So a whole bunch of different things. So that's one of the benefits. Try to do application-based research, validation studies, and things like that. The other thing that I do a lot of is training. I know that many of you are past students and that you've taken photogrammetry courses or cloud compare courses or something of that nature. And so that's great. Thank you for attending here today. But yes, I do a lot of training on the laser scanner. I'm a Faro certified trainer. So I do their forensic training, and I've trained just dozens of agencies and sort of lost track of how many people. I don't keep count anymore, but training is definitely a big component of what I do. Now, I am streaming to YouTube right now, and a couple of years ago, I sort of gave a bit more emphasis to the channel that I have. So I've been posting a lot of information on YouTube. So I figure it's good to share this information. And so if you go to my channel, it's 3D Forensics. If you're more interested in the like the things that we're going to be talking about today on 3D technologies, photogrammetry, laser scanning, then the playlist is Click 3D. There's a good playlist there where I have a whole bunch of different episodes. However, a couple of years ago, I started a little talk. It's called Forensics Talks, which is where I interview a number of people from around the world, people that are working in accident reconstruction or people that are doing different types of things inside of the forensic area. So it could be for DNA, it could be forensic genealogy, it could be a number of different things. So if you're interested in that, just do a search for Forensics Talks. It should come up. It's usually every Thursday, of course, Thursday at 2 p.m. So actually this time slot is actually normally for Forensics Talks. And then during the summer, I have a little bit of a break, but that's pretty much it. There's a number of things here that you can pick up. And also, I should mention that I will be having a Recon-3D channel on YouTube soon, where you'll be able to just get a lot of tutorials and educational videos and stuff on the iPhone. So just keep that in mind, please. Okay, so what we're going to be covering today are a whole number of different things. And like I said, I don't want to rush this at all, but I'm going to give it as much treatment as I can without going too long. So the first thing that I want to do is I want to share the poll results. So there were a whole bunch of you that actually filled in the poll. So I didn't think I was going to get that many people filling the poll, but I did. So that's wonderful. I'll share the results with you. And just to kind of give you a layout of who the people are and experience levels and things like that. We're going to be talking about different types of 3D technologies and forensics. Why Recon-3D? Why an iPhone app for forensics? We'll talk about the technology a little bit. We'll talk about different iPhone apps that are out there today and sort of what their strengths and weaknesses are. And then I'm going to go into Recon-3D more. So I'll talk about the workflow, different applications. I'm going to show you a number of examples. And I also have some interviews that I've done with some people talking about the technology, the engine behind Recon-3D, and also some of the beta testers who are giving feedback on the results of their testing. And then finally, I'll talk about Recon-3D, when it's going to be available, and what kinds of things that we're going to be offering here. So no problem at all. Good. So let's talk about this. So why would I want to develop an iPhone app for forensics? And so there's a little bit of a story behind this. And part of it just has to do with the fact that I've been doing this for quite some time. And so these white hairs here are probably part of the reason. And when I first started, I think many people today are probably in the same situation, that people who both experienced people and new people that are getting into forensics or getting into this area. And what happens is you need equipment for documentation, and there are different tools that you can use. I think we'll discuss some of those tools, but some of them are quite expensive. And so initially, when I started making a $30,000, $40,000, $50,000 investment, is a big step. It's a lot of money, and you have to think about the return that is on the investment. You know, how many jobs you have to do. That's what the first thing that crosses my mind. How many jobs do I have to do to pay off, you know, something that is rather expensive? So you're just going to have to, you know, sometimes you bite the bullet, you buy it, but having low cost alternatives is really important. And that's why I think photogrammetry is a fantastic resource. And I've been promoting photogrammetry for years now because I've just been absolutely thrilled at the type of results and the kinds of things that you can do with, you know, something that just requires a camera and, you know, and software, for relatively low cost software. I mean, some of it, you know, some of it can be thousands of dollars, but considering what you can do with it and how flexible it is, it is also a great value. Now, the other thing here that I think is important is there have been other technologies and other companies who have really good products. And so some of those have been people that I've worked with in the past. And I will give a shout out to Dot Product, for example. Great people there, excellent product. I've said it before and I say it again. What they're doing with that sensor is really incredible. Okay, they're doing some really, really amazing stuff. And so that's really fantastic. But somebody said this to me once, and I actually felt the same way, but I didn't put it quite in these terms. And if you were to think about a hierarchy of technology, and let's say the laser scanner was at the very top, and then you had, you know, other kinds of technologies, maybe a total station or photogrammetry, and then you think about the apps on the phone. They're sort of lower down, and you know, and there's quite a large gap in between. And I believe now with, you know, for example, with Recon-3D and the engine that's driving it, it's closed that gap significantly. Okay, so it's made a big jump ahead, I think, of the other apps, and I think that is probably what has pushed me to help develop, you know, the move forward with Recon-3D and develop an iPhone app. The fact that this is readily available in your back pocket is a big plus. The fact that it's familiar and easy to use, your phone you use all day long. People have it with them all the time. So opening the screens and you know, sort of manipulating the screens and feeling comfortable with the phone is not something that you have to overcome with a new piece of equipment. So it is an important point. And also, you know, having you know, phone apps, or for example, using mobile devices for forensics is not something new. And actually, in January of this year, I had a symposium. It was called the Forensic Photography Symposium. And two of the presenters there, is Robert Wyman and Larry Stringham, they had a presentation on phone apps for forensic use. And they raised a lot of well, let's say, for example, issues that people maybe come up with on, you know, hey, this is on a phone, and you know, what's the, you know, it's not going to get accepted in court. They're gonna pull your device out of your hands, and you're never going to get it back. It raised a whole bunch of different concerns, and it was interesting to see that. I think a lot of the issues and concerns were probably a little bit overstated. And there are already people using mobile devices in forensics. So people are using their cameras, they're using other things inside of forensics. So crime scene investigators and accident reconstruction people use it all the time. And to sort of make that point, someone or a company that is really doing a lot with mobile devices is CrimePad. And so, you know, this is an evidence management. You know, I'll simplify it that way. I know it does a lot of different things, but it's made for the iPad. And so if you're a crime scene investigator, you know, you're able to take a mobile device and then, you know, take photos and, you know, log it and take notes and do all kinds of different things and manage that evidence as well. So the fact that you have something existing that's out there and that is currently being used certainly gives support to you know, something like Recon-3D in the application of, you know, Lidar scanning and documentation of evidence. Okay, so let's talk about the poll results. And I thought this was kind of interesting. There were some really good comments that came back, and so it helped me. It helped me to sort of customize this presentation that I'm going to be doing, or this webinar, and helping to answer a lot of the questions that were there. So first things first here, what areas best describe you? Okay, so what are your backgrounds and things like that? So here we see we have a large amount of people accident reconstruction, and I'll have to say that the majority of people that I have been dealing with have been people that are working in the accident reconstruction world. They've been reaching out to me, and I would say that they are probably some of the most excited people about this particular product, which is great to see. Right behind it is just a whole number of different forensic professionals. So if you tie in some of these other areas here, like shooting reconstruction, archaeology, and stuff like that, bloodstain pattern analysis, and sort of put them on top, they're almost split 50-50 here in terms of the forensic accident reconstruction, and crime scene investigation or other types of forensics investigations are split pretty well. And then you can see you've got engineering, a whole bunch of other types of areas, a lot of students here as well. So that's kind of the breakdown. But you can see the majority here are people already working either in the accident reconstruction world or in forensic investigation somehow. In terms of the level of experience with these iPhone apps, you'll see that the vast majority of people are relatively new. And, some people know what it is and they may have tried it, but maybe not, sort of gotten really, really heavily into it. So, on the other end, the experts and some of the people who are, fairly regular users, much, much less. Okay. But you can see I've put the numbers up here just for your own information to see what the number of respondents were. But like I said, it was very, very, very well. There was a lot of good numbers on the polls here. Biggest challenge. So this was important for me to sort of understand what was it about having a mobile scanning app that would be helpful. And I've heard some really interesting things back from people, and I'll bring some of them up during the webinar today. Some that I knew were advantageous, but I didn't think they were such a big deal. But for some people, it was. So we'll see what that looks like after. So learning new skills. So a lot of people are interested in just adopting these new technologies and these new techniques. So that's good. And then it looks like people like something new. They want to learn something new. But of course, people are talking about quality and accuracy, and maybe some of the challenges that are going there, lowering costs, and then on the other end, speed and portability. So that's kind of the layout. But definitely learning new skills and techniques is a big one. And then what are you looking to learn on this webinar, or what kinds of things that you want to have me cover? And so here you can see that I've got learning the workflow and the techniques. So I'm definitely going to have a component of that coming later on. General knowledge of Lidar. I am definitely going to have a component of that. Applications for sure. Accuracy and precision and limitations. I will be talking about that too. And then there was a bunch of other stuff. And that other stuff was a whole bunch of different things. So some of those I will get to. If I don't get to your questions, then what I'm going to do is at the very end of this, it'll be easier for me to hang back and then answer some questions at the very, very end. So please don't put in any questions just yet, because there's a lot of people on here and I'm just not going to be able to follow it all. Okay, so I'll open up a question and answer period at some point, and then you can post everything at that time. Okay, so that is the poll. Now let's talk about 3D technologies in forensics and what some of the most common tools are today. Now, I have left out the tape measure, the good old tape measure. There's nothing wrong with a tape measure, and just because I deal with 3D tech doesn't mean that I don't believe that it's useful. It is useful, and in fact, with any of these instruments that are up here on the screen, I always bring a tape measure with me anyway, and it's for reference checking. It's for your own sanity to make sure everything is okay, but it's useful to have. So keep that in mind. But I put these in order from left to right in sort of chronology. And photogrammetry, the first one on the left, is actually the oldest technology of all of these. Now, of course, modern day or digital, photogrammetry is something new. It's not something that's been around forever. But the roots of photogrammetry date back to the 1850s, a very, very long time ago. And there's even evidence that shows that some of the early accident reconstruction people in Switzerland, I believe it was, in somewhere around the time, and if I'm not mistaken, I believe it was around the 1920s or 1930s, a very long time ago, they were using stereo photogrammetry, and they would have two cameras on a bar and with a known offset, and they would be taking photos of collisions. Is pretty amazing how old this is. In fact, so that's about almost 100 years ago. Then, of course, around the early 1990s, we get the total station. Later on, late 90s, we start getting the first laser scanners coming out, looking a lot different than what they do today, for sure. And then, around the 2005, 2010, we get, a lot more modern looking and operating laser scanners. Structured light is something that also came around the 2000s. I mean, it's been around for a little while, but not a heavy adoption, but a lot more definitely in the past 15 years. So that's really taken off. And more recently, since 2020, Lidar has been packed into some of the iPhone models. So the Lidar-based instruments, so light detection and ranging, the Lidar-based instruments are the total station, the laser scanner, and the iPhone. So all of them have a sort of a similar technology that they're using. Now, of course, the operation and such is a little different, and I will get into some of that a little bit later. But I want to talk I want to look at two different technologies, and the two which are probably the most popular today. So one is the laser scanner, and the other one is photogrammetry. So those two are very popular, but I want to talk about those in terms of where they are useful, and sometimes what are some of the downsides to using those, sort of what their limitations are. So let's start with the laser scanner. Now there are the laser scanner uses LiDAR, and there are two techniques, or there's a couple of the most common two techniques are time of flight, and the other one is phase comparison, or it's phase based or something like that. So time of flight is pretty simple to understand. And what happens is that the scanner emits a very, very discrete pulse. Okay. And I just noticed that you can't really see the, or at least on my screen, I can't see something here. Oh, no, you can see it there. Okay. Just a little arrow there. So basically, if you took a flashlight and you turned it off and on really quickly, so just kind of flashed it on, so, for a fraction of a second, it's a very discrete pulse. And that pulse goes on, and what it does is it goes to hit a surface or a wall or a car or whatever it is that you're working on, and that's part of the signal will return back to the scanner. And during that time, from the moment that the pulse is released, it's being timed. So there's a little timer, a little stopwatch that goes click, and it waits for it to hit the surface, come back, and then it goes click again. And basically, based on the known speed of light, which is a constant in a homogeneous material, and based on the time, you can do a simple speed calculation. Speed is distance over time, and you divide the time by 2 because it's a round trip, and then you get your distance. So it's a lot more complicated than that, for sure, but that's the basic premise. The other type of scanner is a phase-based scanner. And again, it's also a LiDAR device. It's just a different technique. Now, the big difference here is that the time of flight scanner or pulse-based scanner sends out a very discrete pulse. But when we talk about a phase-based scanner, it is always on. When it's scanning, it's always on. Okay. And basically what it's doing out is sending waves, it's sending signals. And those waves go out and they hit a surface, and then they reflect back from the surface. And when it's on its way back, eventually it hits the receiver. Now, depending on the wavelength and things like that, it will determine how much of a shift that you get. So basically, there's a little shift between the outgoing wave and the ingoing wave. And the difference between those two will help you to determine what the distance is to the wall or to the object that you are scanning. Now, it does get more complicated than this, okay, because there are other factors involved, but that's the basic premise of a phase-based scanner. Now, both of these will use infrared lasers, okay? So it's above the visible spectrum of human vision, and this is a Ferrofocus 120, and I believe this is a 905 nanometer range laser that's being used. So the only reason that I can see it, and what I'm going to do here is I'm going to pause this for you on the screen so you can see. Let me go back a bit. Usually when it's on the left side here, it comes up the best. And let me see if I can, there you go. So what you're looking at is this little line that's on the wall. So if you imagine a laser pointer and you were to take a photo of it when it's passing the wall really, really quickly, you basically, it's basically, you're not stopping the little dot on the wall, it streaks. And so that's what you're seeing here. You're seeing a streak. But if you imagine a dot that is the diameter of the thickness of the line or the width of that line, that's basically what it's doing. It's emitting out this little dot that's moving around. So let me go here. But this is a phased-based scanner, and there's advantages and disadvantages to both. But basically, this is what you're getting. You're emitting a signal. The signal comes back to the unit. It's being detected, and based on what was going out and what was coming in, either through time or phase shift, you are determining something about it. And a lot of people are familiar with the laser scanner, for example, something like this for documenting, crime scenes, crash scenes, fire scenes, all kinds of different things. And the beauty here is that you're looking at millions and millions of points. These points, each point has an XYZ coordinate. You can measure between any 2 points, and it's also assigned color. So it has an RGB coordinate. So these types of things, are very useful, both for, the person that is investigating the accident, for example, in this case, but also for example, a judge or a jury or, people who are going to be on the receiving end. Okay. So when we talk about terrestrial LiDAR or these types of scanners, we have to think about, what are the pros and cons? And the bottom line is, no matter what technology that I discuss today, they will all have their pros and they will all have their cons. So they all have an advantage and they all have a disadvantage. And sometimes not one instrument alone is going to do the job. You need to lean on other technologies. But when it comes to the laser scanner, there are many advantages, and one is long range for sure. So many instruments now can go hundreds of meters, although the useful data is often in the first 20, 30, 40, 50 meters or something like that. They collect massive data sets. So if you need a lot of data, the laser scanner does a great job. It collects, just millions and millions of points. So you have a very good accounting of the environment or the object that you are scanning. Accuracy is also a big plus. These are calibrated instruments. They've been validated, they've been tested. There are, this is something that I've done a lot of in the past few years, and publishing papers on accuracy and repeatability and how the scanner can be applied to things like bullet trajectory documentation or bloodstain pattern analysis and a whole bunch of different things. So definitely a big plus on the accuracy side. And accuracy is you can have a big discussion about accuracy, but basically, in a controlled environment, these instruments are good to, a couple of millimeters, 1-2 millimeters, depending on how far you are and, the type of surface that you're hitting, but very, very good. And the other advantage that a lot of people don't really talk about is the fact that they have various outputs. So, the scanner is capturing photographs, it's creating panoramic images. So you can create, you can just give, 3D data, you can give a whole bunch of thumbnails, you can give panoramic images, you can create virtual tours, you can create animations. So a lot of different things you can do with this data once you have it. So very, very powerful instrument for sure. Now, on the downside, what would you say are some of the negatives to something as powerful as a laser scanner? Well, there's a few things. One is that they are stationary setups. So typically you drop the scanner in place and it can't be moved. So basically it does its scanning, it rotates around. Once it's completed, then you move it to a new position. And sometimes when you have tight spaces or you have to get underneath something, then it can be a little difficult. So the where you place it, the fact that it has a tripod or whatever, you just have to have other equipment for it to kind of set it up. But the stationary setup, it's not mobile. Portability. So this one I actually found interesting. There were a few people who came back to me and said, with a phone, I just put a phone in my pocket and I kind of can go do a vehicle inspection, or I can document, I can pull it out really quickly at a crime scene or something like that. And so a few people had mentioned, and I don't know if it's just coincidence, that it was a pain checking it in at an airport or having the case and the tripod and maybe some other things with it as well. So, it is a small instrument, and I would say it's fairly portable, but certainly not, not as portable as your phone that's in your back pocket. So portability, when compared to the phone, is, there's definitely a difference there. Documentation time. Now, that one is relative too. So it depends on what it is that you're scanning. But, because, if you're doing a building or whatever, if you were to compare it to a mobile device, then there's an advantage and disadvantage. So the advantage is that you take a hit on documentation time for accuracy, right? So you pick up the accuracy because you have a nice stable device. But on the flip side, if you need to move fast or you want to move faster, it's a little bit more difficult to do with the scanner. Whereas with a mobile device, it's a little bit easier. You can move around, you can get into smaller areas where you need to, and kind of go from there. Cost. So if you think about the cost of the investment, maintenance, training, things like that, there's a cost associated with that, right? So on the training side, using the software and being able to, just understand good surveying practices and things like that. There's obviously some education that needs to happen. So it's not like you just walk into it and you learn it in an hour. There is some training that's required, and yeah, it's an important part of the process for sure. The other one is that there are some things that the scanner just doesn't do. So glass, very black, dark surfaces. A lot of scanners these days actually do a pretty good job of it, but you'll find that you get more noise, you get more errors. Reflective surfaces can cause a problem. You get a lot of streaking, a lot of, I'll call them artifacts for lack of a better word. So number of things here to consider when we talk about the laser scanner. Now, photogrammetry, modern day photogrammetry, if you think about it in terms of, what do people kind of know what it is? Well, you take a lot of photos, you upload them to software or the cloud or something like that. And basically in the end, it spits out some kind of a 3D model. And so there are some good things you can do with photogrammetry. This is a drone flight that I did when I was in Chicago with, it was during a training class, and the police officer that was with me had a little small drone, and I said, "Hey, let's fly it over this building. It looks kind of cool. It looks like it's destroyed." And so 7 minutes of flight time, right? Very, very fast. We were across the street. You didn't have to walk into this area, so it was at a safe location. Took a number of photographs, processed, and you get a really nice 3D model. But even photogrammetry has a lot of limitations. And so, some of the pros I already talked about. The camera is readily available. So everybody has a camera. They're on drones, they're in your back pocket, in your mobile phones. They are, on digital SLR cameras that people already own. Very portable, lower cost than a laser scanner for sure. The software, maybe a few $1,000s. And like I said, if you already own a phone, then you can create a model. But even, investing in a new phone, a good phone, a good camera, digital SLR camera, is a couple $1,000s is more than enough to create good 3D models. Very portable, small, and yeah, there's some good things here. Actually, this no scale here shouldn't be here. It should be on the other side. that got flipped over here. So the other thing is on the con side. So this no scale should be on the other side. I'll make sure that I correct that in a little bit. But requires textures on surfaces. So photogrammetry does not work on a flat white wall. If you try to do something like that, and many of you have, you've tried, you'll know that you get garbage. Okay, you don't get anything good back or anything useful. So it's also difficult on indoor spaces. So if you have a tight indoor space, it's a little bit difficult and much more trickier to create a good photogrammetry model of an indoor space. It's a little bit of an art for sure. So, photogrammetry likes to go around an object. Okay, so like if you imagine a drone, it likes to be above the object and fly around it. If you have an object in front of you or something on the ground and you can walk around it, those are ideal situations for photogrammetry. But they also suffer from surfaces which are shiny, reflective, and things like that. Okay, they're problematic. Now, of course, you're taking photographs. So what do you need for good photographs? Well, you need good lighting. And you're limited by good photographs. So if it's at nighttime and you don't have good lighting, you better know how to use your camera to get a properly exposed image. Otherwise, you're going to have some problems. Now, the other one that throws people off too, and is a little bit of a pain point for some people, is the fact that photogrammetry has no scale. And I would say it's a benefit. Actually, maybe that's why I put the no scale there. I think it is. And the reason I put that there was because it's flexible. So I can take my camera and take a picture of a sneaker, of something small like a hammer or a knife. But then I can put it on a drone, and then I can do, a kilometer or a mile of roadway. So it's flexible in that regard, and that's a pro. But on the flip side, it means that it has no scale, and you have to provide it scale either through GPS, either through control points, either through a reference measurement or something else. And the accuracy of the photogrammetry reconstruction depends heavily on the GPS coordinates, control points, or scale reference measurements. So all those things are very, very important to note, with respect to photogrammetry. So that leads me to the iPhone and the Lidar sensor. So just so you know, the Lidar sensor is, and this is a question that has come up, is available in the iPhone 12 Pro or iPhone 13 Pro, and also the Max. So the Pro and Pro Max models, but also on the iPad Pro. Okay, so the iPad Pro will also have the sensor that's built in, and it's this little black black circle that you can see back here. So on my phone, if I put it up to the screen, it's that little black dot that's right there. It's absolutely tiny. It's this tiny little thing. So that little sensor has been built in the Pro models and the iPad Pro since 2020. And so we've got the iPhone 12 and 13 2 models, and I'm expecting the following models that come, the 14, 15, 16, are likely going to have them as well. Now, where does this thing come from? Well, it's not that easy to find information on Apple's products, but by all accounts, and correct me if I'm wrong, if anybody has other information, I'd love to share it with you. But there's a lot of rumblings here on the internet about Sony being the supplier of this depth time of flight LiDAR sensor. So there are a few things. There's some things with patents and stuff like that. So that's what it seems like. It seems like Sony is the supplier. I don't know for sure. Okay, that's just what I'm seeing online. And if we were to take a look at this on the inside of the iPhone, it's just behind that little black dot is this little sensor. Okay, it's this guy right here. Okay, that little thing right there. It's tiny, absolutely tiny. So it looks like there's a transmitter and a receiver here. So something that projects out some of the infrared, okay, like here, and then maybe something that receives. And I'm not really sure which one is which right now because I don't have a lot of information on this particular sensor. Now, what does the sensor do? Well, the sensor throws out a series of dots. So let me show you something. And this is something I recorded last week. And let me press play here. So this is a video that I did. I have the iPhone 13 Pro Max on the left side, and I have the iPad Pro on the right side. And they're about the same distance from the wall. Okay, so the sensor is roughly the same distance from the wall. And you can see that the projected patterns are very, very similar. And you can also see it looks like that they are shaking, okay, like they're doing this vibration thing or something is going on. So I'm using an infrared camera. It's a full spectrum camera, and I don't think I put a filter on this one, so it's just full spectrum. But I've shut the lights off, so the dots become very, very pronounced when you do that. And if I take the video and I slow it down, so let me do this. And what I do is I just take a couple of frames. You'll see that if I cycle through, I'm just going to cycle through my slides here back and forth. You can see that you have this shifting grid or pattern of dots, and the grid is 12 by 24 dots. And like I said, you just go back and forth, and that's what they're doing. They're shifting. So it's quite a novel technique, because what I'm thinking is that they're doubling up and shifting, and this allows you to get some increased points. So instead of having twice as many points, of having a grid of 24 by 48, you use 12 by 24, and then somehow you move it around, and they can do some other fancy things there. So that's what presents itself from from the sensor. That's what the sensor is doing. Now, when it comes back to the sensor, you're basically taking a snapshot of this and you're creating a depth map. Okay, so a depth map is something that's used a lot in computer vision. And this is an example. This is an example here. So basically, you have a person, but when you put the sensor on, you basically get the sensor senses the distance. So basically, things that are closer, things that are farther away. And on the right here, these two images are from Recon-3D. So in the top right, you see that there's a little depth map. And I'll talk a little more about this because it's actually quite useful. And originally, I wasn't looking at this a lot. I was just kind of looking at the main video screen. But I actually start looking at the depth maps a lot more in my scanning and in my scanning workflow kind of thing. So, but this idea of the depth map is really, really important. So the Recon-3D engine is driven by EveryPoint, and EveryPoint is probably a name that a lot of you have heard online. They've been making a lot of posts about their technology and that sort of thing. And what got me interested in doing this whole journey was the EveryPoint technology. And at the very beginning, the first time that I had seen some of the data that had come out of the EveryPoint engine, I was like impressed. I was like, okay, that looks pretty good. That is crisp. It looks solid. There isn't as much noise as I would have expected. And so they introduced me to the term sensor fusion. Now, sensor fusion, I never heard it termed that way, but basically even I've thought about, hey, if I could only take photogrammetry and I can only take the laser scanner and I can put those two together, right? If I could put them together, I might be able to get something that, any one of the technologies alone couldn't give me. And that's in fact what I believe is happening here with this EveryPoint engine. So when we talk about sensor fusion, we're talking about different things that are on the iPhone. So obviously the Lidar sensor, which is giving you the depth maps, right? But we're also talking about the gyros and the accelerometers. And basically, we're looking at position and orientation. Where is the camera in space, and how is it being oriented? So the sensors that are on here assist with making those types of determinations. And I am really impressed with how robust the tracking is on the phone. I sometimes on purpose I'll move it rather quickly, and I'm quite surprised that it can still hold on, to figure out where everything is located. And of course, there's camera, right? So it's recording video. So you've got the LiDAR sensor, and then you've got camera video, you've got the accelerometers and gyros, you've got a number of different things that are going on, and that's all being recorded. And by taking all that information and then basically fusing it together, you basically end up with something that spits out a really nice model. Now, I had the pleasure of speaking to Jared Heinley, and he's the chief data scientist at EveryPoint, about some of the technology that they have and some of the things that they are doing. And so this is a longer, I took excerpts from a longer video, and at some point in the future, I'll post the full video online for you, because there's a lot of really good information in what they're doing. But let me just play this short clip, and then I'll come right back as soon as it's done.
Yeah, so at the moment, so the LiDAR and the Apple sensor, it provides us with depth readings, rather low resolution. It's like 256 by 192 pixels resolution depth readings from that. So which gives us sort of for free depth estimates of what's in that scene. And so that can be used to accelerate a lot of different algorithms or processing. When we're trying to infer, well, what is the final depth of the scene? What's its 3D shape from different angles? And gives us the ability to, in environments where a photo-based reconstruction algorithm may have failed, like a blank wall or textureless surface, where I can't actually distinguish one pixel from the other, that depth sensor is able to give us a depth reading,
Okay.
And help recover those depths. What's nice with photogrammetry is that photogrammetry, I call it an offline process. It's, once you've captured all of the data, you finish your data capture, and then you begin the processing. And so photogrammetry has the ability to look at all of that input imagery, I'll look at all that input data, and then make its decisions based on that best sort of global understanding of everything that's been received. And so if you were walking around, a car or a vehicle, you're going to have perhaps, one loop around that vehicle, two loops around that vehicle, something like that. And so photogrammetry is able to say, oh, okay, well, I see these multiple loops. Here's an image that sees the front of that car from two different elevations or a few different angles. Let's use all of that imagery to help estimate the best camera position, that gets camera pose in that reconstruction to get that result. And with that sort of global reasoning, we use the word called loop closure. So automatically being able to detect, when the camera has returned to a similar position, closing that loop. We're able to, photogrammetry is able to, perform that reasoning, detect that these images are from the same area, and then have those images align. The other real key piece about why the results that you're seeing that are cleaner is just due to our algorithms. So we've spent a lot of time optimizing our photogrammetry algorithms to produce clean results. So it's there as opposed to just saying, hey, I've got all these depth readings and let's just throw them into 3D space and hope that they align, or hope that they're not noisy. We're doing volumetric reasoning, trying to figure out, okay, well, I've got all of these different depth measurements of a surface, where is that true surface? And, fusing those different depth values together. And so that's where we get the benefit of, that raw LiDAR data, that raw depth data may have been noisy. There may have been some misalignment. Our image-based depth maps may have missing parts, like you said, like that shiny car. It's really shiny and reflective. We're gonna have a hard time reconstructing that using images alone. But by combining these two sources of data together and figuring out, well, where is that actual surface, we're able to produce these, really, really nice, clean results.
All right. So Jared, if you're there, thank you so much for the information. Like I said, at some point in the future, I'm going to make sure that this goes online. The full interview goes on. Lots of great information that was passed along. Okay. So I'm not going to talk too much more about the technology. I think that gives you sort of a general overview of what's happening. I think the most important point here is to understand that what's happening behind Recon-3D is a fusion of the LiDAR and photogrammetry. It's two things in one. It's not just photogrammetry and it's not just LiDAR. It's that fusion, that putting the two together, one helps the other to get you some better and more accurate data. So what I wanted to do now was discuss a little bit about some of the different iPhone apps and the technology that's out there. Now, I have to admit that I have worked a little bit with these different apps, but I'm not an expert in any one of them. So, kind of going in, playing around with it or whatever. And if I'm mistaken on some of this, somebody can correct me for sure. But this is what I believe to be the case on some of these, and I'm sure that there's some additional technology behind and under the hood of a lot of these little apps. So Polycam is a very popular app. A lot of people have been using this one. It's been around for a while. They have a pretty good interface and everything else, but they offer a couple of different modes. So one is a photogrammetry mode, and then one is a LiDAR mode. So they're using one or the other. Now, one thing that I'm not sure of, and that is that they could be using the LiDAR to help with positioning and things like that, but it doesn't appear that they're doing any type of fusion, that they're not taking the LiDAR and the photogrammetry and then putting them together. So when we look at something like Scaniverse, this one here looks like it is primarily LiDAR based. Okay, so it's pretty much just doing the LiDAR. It does have some other little features in there where it's doing some different things, but no fusion and no photogrammetry only option. So you're pretty much getting an optimized version of just the LiDAR data. And I'll show you what that looks like in a little bit. Also, the 3D scanner app. So the 3D scanner app, again, also an app that uses primarily the LiDAR sensor that's inside of the iPhone, and doesn't appear to have like photogrammetry or whatever. Now, it is taking color, it is taking the color imagery from the camera and then applying that. And many of these apps will produce a textured mesh, and I think that's an important point. Okay, so they're creating a meshed object and not just a point cloud. So in order to make it look good, you put a texture on it, and it helps it visually look more appealing. Pix4D Catch, again, this appears to be a photogrammetry-based app only. And I've spoken to some people also who are more experienced with this than I am, and it appears that even when you run, for example, the app on the phone against, for example, Pix4D, you end up with an identical result. So there doesn't appear to be any enhancement of using it on the phone or using the Lidar. So again, doesn't appear to be any kind of fusion happening there. Now, with Recon-3D, I guess two important points. One is that I only provide the fusion. So there currently is no option to have a photogrammetry only mode. And that's because there's other apps already that do that. And also because the fusion tends to give the best results anyway. So only focusing on the fusion, and also at the moment, we're only providing point cloud data. Okay, so the point cloud data is the raw data that is comes out of the fusion engine, and basically, it's clean, it's crisp, and that's what you get. Okay, so in the future, there could be some opportunities for doing other things like textured meshes or whatever, but the focus of Recon-3D is on point cloud data that's accurate and it's clean. And so that's the starting point. So, I don't want to jump ahead too far and start doing all kinds of textured mesh things or whatever, because as soon as you start meshing, you're going to start getting into some other areas where you start getting artifacts, and the meshing process itself will interpolate between areas where you don't get a lot of data. So there's a lot of things that has to be considered. But in a nutshell, this is just a very quick comparison, or a very quick table here. And I'll give you some examples. So the 3D scanner app gives you they have points mode. And so in the points mode, you can basically see the raw data from the sensor. And I don't think there's a lot of optimization going on here. And if you look at this data that's on my screen, it's not all that crisp or clean. You can see it looks grainy, it looks fuzzy. And there's also some noise. So for example, if you look up on this edge here, there's something going on there. So it's either a reflection, or it could be a problem with loop closure. And so loop closure, Jared had talked about that, or he mentioned it. But basically, when you end up going around an object once, twice, or three times, if you don't have loop closure, what ends up happening is it's about the same as walking in a straight line. Okay, it doesn't recognize that you've passed the same area, and it can adjust those two surfaces on top of each other. Basically, what you're getting is an accumulation of errors across the entire scan. And so what happens is, as you continue, your scan ends up drifting. Okay, so when it should be here, you start accumulating small errors, and it drifts. When you have loop closure around a car, or a forested area, or a building, or a room, when you get that overlap, there's some redundancy there, and it's able to fix some things. So loop closure is also an important part of of producing a very good point cloud and mesh. Now, this is Scaniverse, just an example. And again, if you look at the model, I mean, they make models very quick, very fast, textured. They look pretty good. Okay, they look pretty good. But I think that if you had to use this for evidentiary purposes, if you look at some of the models here, and I don't know how well this is coming out on the screen, but you can see that if you follow the body line, there's a mismatch here. Also, if you look here, if you look up here where the door is, you can see that there's this line that gets mismatched as well, especially here near the top here where the side view mirror is. You can see that there's a mismatch there. Now, some of this may be just textures that are mismatched. Some of it is geometry that's slipping. Maybe it doesn't have loop closure. So there's a number of things that you have to consider when we discuss accuracy, what do we actually mean by accuracy? Do we mean just the overall size, or are we also looking at individual components and smaller components, localized errors of the scans as well? 3D scanner app. So this one here, they have a laser advanced mode in a similar fashion. If you look here, look at the body line, we get some slippage. Here we have a same kind of thing. And, this was a pretty simple scan, so there was nothing fancy. So, this is very common. This is something that you'll get a lot of. And I just see somebody commented here about, Scaniverse doesn't like areas of overlap. And if you don't have loop closure, then that's going to be a problem. Polycam has both a Lidar mode and a photogrammetry mode. And photogrammetry on vehicles is problematic, okay, no matter what. I've tried it many, many times. I've gotten some half decent results, but there's always an issue with the shiny reflective areas. Those are just killers. And it's not a limitation of the fact that Pix4D can't do something, or that, Metashape can't do something. All these programs are based on the fact that you have to detect features in an image. And when you have something shiny, it just becomes problematic. And if you have a plain white wall, there's no way to distinguish one pixel from another. And that's just the nature of the beast. And as a result, you start getting all kinds of strange things, like over here on the side view mirror, over here on the top, for example, the photogrammetry capturing the top surfaces of the vehicles and things like that are pretty problematic. Now, photogrammetry for asphalt, for a forested area, for things that have a lot of dirt and rocks and things like that is incredible. So you get a fantastic result, because those types of environments or objects are well suited for photogrammetry. Okay. Now, in comparison, if you look at a scan from, this is from Recon-3D. This is a very simple scan. This is an early one. I even went back. I just took an older one, and I could probably do better today. But this is a very typical type of output that you would get from the phone, with about somewhere on the order of 1 minute and 30 seconds or 2 minutes of scanning. Now, in this particular one, I just happened to see it, and I did it. I didn't do it. I didn't have a selfie stick. I just had my phone with me, so I just walked around real quick. So I didn't get the roof, and it was just an example. But what I want to point out here is these sides of the vehicle that are just flat white, those would cause all kinds of problems for photogrammetry-based solutions. And here, we're not getting those kinds of issues. So the LiDAR sensor is helping the photogrammetry reconstruction as well. Okay, let me talk about the basic workflow inside of Recon-3D. That's a question that came up. Hey, how does this thing work, and what's the basic workflow? So there's a few other little things that you can do, but there's basically 4 steps to get you going and to get you scanning. Okay, so the first one is you have to create a scan. So when you get in the app, it's relatively simple, and I kept it simple. Okay, somebody always said make it cop friendly. So that's what I've tried to do. So there's 3 buttons. Okay, so at the bottom there's a scan folder. So whenever you scan, you finish scanning, it dumps everything in that folder. There is the create scan button. So that button is just, create scan, and then it gets you going into the scanning. And then there's your, what I call the more tab. So there's more information there, settings, information, whatever you need. Okay. So 3 buttons on the main screen, and that's it. And I don't want to see any more. Keeping it simple is good for me. So that's the first step, creating a scan. So you would hit the plus button, create a scan. And then you get into, you name it, and then you get into your scan settings. So I'll spend a second talking about some of the settings. So the first button at the top here says the start stop tone. So if you're going to be using this on a selfie stick or a pole or something like that, because some people are doing that for vehicles, then there's a timer, and there's some other things coming that I'll talk about later. But basically, it gives you an audible tone whenever the record button is hit, or you hit record, the timer counts down, and then when it starts scanning, you'll hear that. Okay. Now, the mode is standard. There's only one mode right now. been thinking. There's some things that I may be able to talk about. I'll talk about later, just some ideas. There's nothing concrete, no guarantees right now, but basically you're getting the best possible reconstruction in standard mode at the moment. Then there's scan density. So those of you that do laser scanning, it doesn't work the same sort of way, or yeah, it doesn't work the same way. It's a little bit different. But one thing that is similar is that if you choose a very low resolution, so for example, 1 millimeter, but you're standing very far away from a surface. So if you are 15, 20 feet away from a surface, you're not going to get 1 millimeter. You're going to get a bunch of noise. Okay. You're going to get a bunch of trash. So there's a couple of things that you need to consider, and that is that if you're going to go very low resolution, it's about being closer to the object, okay? Or at some point during the scan, you need to get close to the object to get a lot of those points. Also, it will affect the reconstruction time. If I do a long scan at 1 millimeter, that takes a lot of horsepower. So my general rule of thumb is 1 millimeter resolution, 1 minute of scanning. 2 millimeter resolution, 2 minutes of scanning. So basically 1, 2, 3, 4, 5. If you have 5 millimeters, 5 minutes of scanning. Okay, now that's a very loose general rule of thumb. You can do more, you can do less, but if you were to do a 5-minute scan at 1 millimeter, that is a lot of data, and it's probably not going to be helping you at all because you'll be waiting a very long time. So the other thing down here is another important feature, and that is the targeting option. So as I mentioned before, accuracy is very important for Recon-3D. And the only way to establish the best accuracy is to have some kind of reference measurement. So there are some April tags, okay, these little tags. I'll show them to you in a little bit. And what you do is you lay 2 of them out in your scene or spread across the vehicle, one at the front, one at the back, and you take a measurement between them. You can, however you can best take the measurement, you enter that value at the bottom here. And what will happen is once you've completed the scan and you're processing, it will scale globally that whole point cloud to those exact measurements. So it detects the targets, the center of those 2 targets, and will scale those points properly. Okay, so that helps. So it's very quick to run through these, and you can even set up default settings. So if you were to go into the More tab here, you can set these up so that every time you come back, they're at the exact same settings that you want, okay? Then you need to scan, and we'll talk about the scanning part a little bit more later. But basically, you'll see that this is the screen here. You get a number of points that basically tell you the strength of the feature points or triangulation, and you also have the depth map that's up here too. So that I start looking at that more often now when I'm scanning. But that's what you do. And then you basically hit the record button at the bottom, this big button, and you start and stop it from there. Now, when it comes to recording, there is a maximum 10-minute limit, which is quite a lot. Okay, it's quite a lot for this. And I was actually thinking about keeping it down at 5. I've left it at 10 for the moment. So it's pushing it. I can tell you right now that the 10-minute scan would definitely be pushing it. But most things you can scan in 2, 3, 4 minutes, and it's not a problem. And finally, once you're done and you hit the stop button, basically a screen comes up and it says, what do you want to do? You got the data now. We've recorded all the raw data. What do you want to do? So basically, we can process on the device. So one big concern that's come up is, well, I don't want to transmit my data over the internet or online or on a cloud or whatever. So in the interim, I have an on-device processing, so nothing gets transmitted. It's all processed on the phone. Now, I will say that the algorithm that's used on the device is not exactly the same as what's used on the cloud. It's optimized to accommodate for the lower power that's in the phone. And also, it will take a long time. So one of the penalties you pay when you do fusion is that there's a processing step. You'll notice that's an advantage a lot of the other apps have. If you need something very quick, then a lot of those apps do a really good job, like the Scannerverse, Polycam, because they're fast. And if you just use the Lidar, you can very quickly get a scan. If you just use photogrammetry, you can pretty quickly get a scan. But with the Fusion, it takes a little bit more horsepower. The other option is going to be the process on cloud. You can also save it for later. So if you just want to do a whole bunch of different scans, go save, 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 you can, and then you can queue them up for upload later. And then of course you got restart and cancel. Okay, so that's the basic things. There's really just 4 steps there that you have to handle. And what I'll do now is I was going to get up and do one, but it's a little bit tricky with the phone. So what I've done is I've actually recorded a little video. It's just a couple minutes, and it'll walk you through what I'm doing. And just I made a little mock crime scene here. So let me play this, and it may give you a better sense of how this works. Okay, so this is going to be a very quick demonstration of the workflow inside of Recon-3D. So what I'm going to do is I'll put the screen up on the video here, and we're going to start. So I'm just inside of Recon-3D. I'm going to create a new scan, and I'm just going to name it something. So I'll just call this demonstration or demo. That's fine. I'm going to go create. Then I've got to choose my scan settings. So that's the second step. So right now I'm at 3 millimeters, and that's fine. I'll use that. There are different modes and tones and things like that. And you can also use targets. So I'll turn the targets on. You'll see that there's a target here that I can use. I'm not going to use it for this one. And then I can just go save scan settings. So now I am ready to scan. So basically, I just prepare myself by going over the area, and I just hit the scan button, and there you go. It's starting to scan. I'm just going to move like this, and I'm just going to do a really quick one. This is just for demonstration. So like that, and let's say that this is, I'm just getting the walls a little bit, and there we go. So stop. Okay, so you see that I have a number of options now that are up on the screen. So it says process on device. So I can actually run this on the device with nothing communicating over the internet. Now there are some limitations with the length of the scan because the phone only has so much power. So if it's a 30-second, 1 minute, 2 minute scan, you'll be okay. Anything more than that, sometimes it'll crash. There are some limitations right now, and in the future, hoping to improve those. Process on the cloud. So if I want to do that, I just hit process on the cloud, and it'll start an upload. And once it's done, I'll get a notification back that it's complete, and save for later. So if I want to do multiple scans and I don't want to upload anything right now, I can do multiple, just go save for later, scan again, save for later, scan again. And then when I'm all done, you can queue them all up for upload. I can restart, and I can also cancel. So I'm going to go ahead and just process on the device, and I'm going to let this run over here in the background. Now, some people have questions about the amount of time it takes to process on the cloud. Now, that does take a little bit of time currently, and it depends on the server load. It depends on a number of different factors. So when it comes to processing, the density of the scan will matter, and the length of the scan will matter. Those two things for sure will make a big difference. So if you have a 7 or 8 minute scan, it's going to take several hours. And so one of the limitations of fusing the Lidar with video or with photogrammetry is that the penalty you pay is on processing time. So unfortunately, you have to wait a little bit. Now, for a short scan here, you can see that I'm doing the on-device processing. So usually step 6 is usually the one that takes a little bit of time here. But when this comes through, finishes, you'll be able to see the point cloud. Now, when I'm done the point cloud, you can look at it, you can move around or whatever, but then I will also be able to share it. So the data is stored on the phone, and then I can share it via Dropbox, or if I want to just, pull it off the phone through files or whatever, then that's something you can do. That's not a big deal. And it's an E57 file, so it's compatible with just about every single program. But that's pretty much it. So first thing is create the scan. Second one is to use your settings or figure out what settings you want to use. The third one is to scan, and then the last one is just to process. And there you go. You can see the scan is here in the window. I can move around, and I'll just show it to you here as well. But you can see that it's right there. So it's looking pretty good. That didn't take too long, but that was only 15, 20 seconds of scan time. So that's it. That's the basic workflow with Recon-3D. Thanks. Okay, so yeah, that was it. So let me just bring some things up here, and we'll move on. again, there's a lot more to it in terms of scanning and best practices. I'll go through, I'm going to go through a few other things later on, but I want to push forward. Let me give you just some examples of the kinds of things that I think this can be used for going forward. And by all means, I'm going to show some examples. And if you have any ideas yourself, just throw them in the chat window. If you have any thoughts on when I show these examples, if just tell me yes or no. Like, do you think this is usable data? It would be interesting to know your feeling on this as well. So let me go ahead, and this is a small scene that I did. We have a little room downstairs where we do bloodstain pattern exercises, and so this was a scan of the bloodstain wall, and this took only, I don't know, maybe 30 seconds or 40 seconds of scan time, but it did take time to process. Okay, so definitely took some time to process. And I can see Jared has a question here. And Jared, I'll take yours quickly while this is playing. I'm just going to play it one more time. So Jared's asking, if you want to confirm if you have good data, can you quickly process on the phone and later upload to the cloud? Yeah, you could. You definitely could. Now, sometimes I have seen it where, for example, you get a slightly different result. So something on the phone may be better on the cloud, and typically the cloud would be definitely a bit better. And yes, this is the Dexter room. So let's try something else. Bullet trajectories. So actually on the bloodstain side, I have a student this year, two students actually, Cassandra and Stephanie, and both are going to be working with me to help validate the phone for these types of applications. And so bullet trajectories here. So for example, can we actually scan the rods, or can we put small spheres on there? When I'm laser scanning, I typically use trajectory spheres, and that helps to get a more accurate center, is what I found, of the alignment with the rod. So, there's a little example there. If we move up a little bit in scale, I think this is an interesting one. So for example, bodies at autopsies, or for example, at a crime scene, just very quickly being able to document, hey, there's a body here, do a 30-second scan, you capture some of this stuff, and then you're able to process it later on. And I guess another point I should mention too, and this is a question that has come up, is how do I know what I got? Most of the time you're okay. One thing I've said though, for example, if you're scanning a car, you should be able to scan just a regular sedan or a car in 2 minutes. Okay. Now, if you want to take 3 minutes or 4 minutes, you can. There's nothing stopping you. You can get more data, spend more time in certain areas or whatever. But it's only 4 minutes. So save the scan, do another one. If you're worried, save the scan, do another one. You can end up with 2, 3, 4. You can do as many scans as you want very, very quickly. And, then you'll have a ton of data to process later, and you'll have, a lot of redundancy. So it's not difficult to do 2 or 3 scans of any particular object. Some of the vehicle examples that I showed before, you'll find that, here in Recon-3D, you get a lot of crisp data. This is pretty much, now I did cut out the surrounding data that was around this vehicle, but, it gives you a sense of, the quality of the data that you get, and you don't get, I have seen it before. I'm not going to say it's perfect. I have seen once where there was a little bit of a slip between some of the data, but I think, it's very rare to see. Whereas, if you have photogrammetry or something like that, you'll see a lot more artifacts. Outdoor scenes, so for example, a forested area. So this was one that I did, I guess 2 weekends ago, but I was basically trying to get the area between this tree in the foreground, and then this one here, and then there's another one over here. So, this one here, walking around with with the phone. I was using a monopod as well for a little bit of elevation, and this is the level. And again, this is a point cloud; it's not a mesh, and I haven't edited anything on this particular one. So this is just the raw data as it comes out of the phone. So it'd be interesting to know what people think, if this is something that you think could be usable. Somebody had asked about, for example, clandestine graves. I think Megan Bassendale once said, hey, can I use this for identification of body parts and things like that? So people that do disaster victim identification and things like this. So for larger things, I think it could be quite useful. Large equipment. So I know a lot of the accident reconstruction people don't always deal with cars. They deal with tractor trailers. They deal with large equipment, or sometimes it's just different types of things. Absolutely no problem, in doing something like this. Again, this is probably like a 3 or 4 minute scan in terms of the documentation time, and then you upload it, let it crunch for a while, and then it comes back to you. Another question that often comes up is, how big of an area can I scan? And my answer to that is, how far do you want to walk in 10 minutes? So you can use it to scan larger areas, but I would not recommend using this for, really wide roadways or whatever. But, and part of the reason is just I'm starting small and taking one step at a time. I want to be careful about, saying you can do a whole roadway, without being able to properly validate it. So here is an example of something that I did a couple of weekends ago, and it just out for a walk and then walked up and down this little roadway in the middle 4 times. So, and I used some different techniques, and we'll talk about some of the scanning techniques and things like that in a little bit. So, but this gives you an idea. This is something that you could potentially do, for a roadway. And I've done larger things just to kind of push it and that sort of thing. And you can use it for vehicle interiors. You could do it for just all kinds of different things, interior rooms. I've done a whole bunch of different things, but I'm not going to show you a bunch of scans right now. I think that's plenty, and sort of gives you an idea for some of the different things that you can do. So one thing I am going to do right now is I want to talk about accessories. And the reason is, if you wanted to, this is all you need. You just need your phone and you can go ahead and scan. But you're somewhat limited in terms of reach and being able to get on top of vehicles and things like that. So at this time, what I'm going to do is I'm going to pause for a moment, and I'm going to run over to another computer where I have a desk set up with a bunch of stuff on there. So if you would all just be patient for give me 60 seconds. I'm going to put on another microphone and everything else, and then I will be right back. So if you can all just stand by here, I'll be back in a flash. Okay. So let's see if this is going to be working. Just give me a second here, folks, to organize myself. If you can, in the chat window, just let me know if you can hear me, because I'm using a lapel mic now. I just switched over, and I'm hoping everything is working properly. And I believe I can see myself, so hopefully that's a good sign here that things are working okay. All right. So let's see. What I'm going to talk to you about now are different types of accessories that you can use with your phone and with Recon-3D. So the first thing and foremost is the phone itself and a case. So if you're going to be holding this by hand and you're going to be walking around and waving it around, you should probably get yourself a good solid case in case it gets dropped, in case it gets bumped, or something like that. So on the iPhone, I don't have such a rugged case on here, and that's because this is my personal phone too, so it's hard to get it in your pocket. And this is the The i13 Pro Max is a little bit larger, so unfortunately, yeah, I just have a pretty simple case. However, this is the iPad Pro, and on this one I actually got a ruggedized case. So it's got like a lot of rubber here, and it's got some good features at the back. So there's a little Velcro strap for holding this in place. There's a strap here, you can put it on yourself as well. I don't usually use this, and part of the reason is if I lift this up and this is on my neck, then it kind of stops me from getting high. And there's also a little leg here, so you can prop this up. And this rotates as well, so you can rotate, so you can hold it this way, or you can hold it this way, whatever you like. So you can find these anywhere. I know somebody's going to ask me for probably a list of all these items. I haven't had time to put one together, but I can put one together in the future. Okay, so the other thing, once you've got your phone all set up, is you need some kind of an adapter to hold this in place. And I have a number of adapters here, and so I've got one that is like sideways like this, okay, like that. I'll hold it like this, or maybe like this, so you can see it with the background. That's one type. There's a little one here, so it has a little quarter 20 nut in here that you can put onto a tripod, but it's very simple, just a little knob here that you dial in to spread the little arms here to hug the phone. And then there's this one here. Now this one here I actually like the most, and the reason is that it gives you two quarter 20 nuts. So there's one here at the bottom and there's one over here. And this allows you to mount something else there, and I'll get to that in a little bit. But the other thing that happens here is when you have just this one here and you put the phone in, let me just put it in very quickly, okay, like this, there's nothing supporting the bottom. So what ends up happening is if this is on a pole, it can vibrate a little bit this way. And what I found is with something that has a little bit longer, you can actually rest this, the bottom of the phone rests on this little piece at the bottom here. So it gives it a little bit more stability. At least that's what I've found anyway. For me, it tends to work out pretty well. But like I said, you can find these everywhere. They're cheap. You can go online or whatever, and they're absolutely fine. Now, when it comes to the iPad, I usually don't mount the iPad to a pole or anything, but you can. So there are adapters like this that you can get where you can mount the iPad. You can fasten this to a pole. This one is two little wing nuts. You have to put the pole through, so you have to pull it off and on. It's not a quarter 20 thread or anything like that. This is going to be a little bit more solid. So find whenever you're looking for this stuff for your phone, buy the heavy duty stuff, because you don't want the cheap stuff that's going to like flop around. Okay, so that's the adapters. We talked about the cases. Let's talk about monopods. So monopods are really important, especially if you want to get the roof of a cars or trucks and things like that. If you're doing a tractor trailer or something like that, you need to get above. And so in order to do that, you need something. So you can use a number of different things. This one here is one that I got recently. I'm very happy with this one. It's a Manfrotto Compact. And I like this one for a couple of reasons. The first one is it comes with the ball head already. So it comes with the ball head, and it comes with a GoPro adapter as well. So you get two different style heads with the monopod. You get it's about that long, so it's not really long, extra long or whatever. But when you stretch this out and you get up for any car, or a van or something like that, it doesn't seem to be a problem. This is pretty good. The other feature that I like here is that it has, if I unscrew the bottom here, it has a little quarter 20 thread here. And the reason I like that is because I've manufactured my own little, it's basically a female adapter. It's a quarter 20 nut that's in here. And I have a mini tripod. And so I have one already installed on here. So I just put this on like that. And what I can do is I can screw this on here like that. So I have that. So this would be my arrangement. I might have this. I've got the monopod, and then I put the adapter up here. And this is a very typical arrangement that I would use. Why? Well, when you're moving around and this thing is extended, or you have it like this, you have to always hold this in your hand. So you can't put it down. So this little piece at the bottom opens up into a tripod, and then I can just put it down like this. So when I'm done, if I just want to rest it on the ground for a little bit or whatever, I can just leave it like this, and it tends to work. So it's a good, and it gives you an extra well, it gives you an extra, I don't know, an extra, 7-8 inches, maybe 30 centimeters of reach here if you need it. But that's one solution for you. Now this one here, it's aluminum. It's a little bit more expensive, but you can always get something like this. Now this one is a little bit larger, and this one is on Amazon. This one is someone you can pick up, no problem. They're cheap. It's probably like $30, $40. And it doesn't come with the head or the adapter, but it's just the pull. And I put my own little extension here, and you just do something like that. You can pick one of these up, so no big deal there. Now, if you're doing something really big, then you got to go with something serious. And when I say serious, I just mean something that is a lot longer. So this is nothing more than a painter's pole that you can pick up at the local hardware store. Okay, and this one here is 4 to 8 feet, so 1.2 to 2.4 meters. And I have another one that's the big one. So that one will go probably, I think it's getting up to about 4 meters or so. So this one has a little, you can change the length. So you can just go out, it locks in place, and that's it. But the thread that's up here is what you would typically get on like a broom handle or something like that. So you need to buy an adapter. That's a little adapter like this, and it just threads in like that. And there's also a small little hex nut here, and you can just tighten it up so that it doesn't go anywhere. After that, you just use a regular, I use the ball head and then the adapter, and then you could lean it forward. And you'll notice that these are in a couple of orientations. So one is sideways. It has the phone in portrait. The other one is in, landscape and portrait. So you can use either one. It doesn't matter, but it depends on what you're scanning and what orientation will give you sort of the best field of view for what you're doing. Okay, bunch of poles, all that stuff, great. Okay, let me put this out of the way. I talked about all this stuff. Let me continue on here, and I'm just going to go in. Let me talk about targets. So targets. These are the targets that are being used for Recon-3D, and you can print these out on A4, 8.5 by 11. You can make them larger. You can make them smaller. The problem with making them too small is that they're not going to get picked up inside of the camera view as you're scanning. So the smaller they are, the closer you're going to have to be to them. Okay, and the way the targets work is basically you're going to take 2 of these, and if I was scanning something here on the table, I would put one on opposite end, spread far apart. The farther apart these are spread, and that you can still accurately measure from center to center between the two, then you've got something useful that you can use, and this will scale your whole project. Now, there's some other things that I'm doing with respect to the targets, and I'll show you a couple of things. And these are completely prototypes. They're brand new, but I thought they might be interesting to you. So this is one. This is a prototype that I've made up. Actually, what I'll do is I'll show you just the base target. So this is nothing more than just a flat piece of wood with a little frame, and it's got a nut here, and eventually I'm going to have one on the bottom. So it's got the pattern on here. It's a little bit larger. So this is about 10 inches is what, 25 centimeters by 25 centimeters. That's a perfect size for doing cars and things like that. No problem. That will work. But what I've done is I've mounted it on a tripod like this. And so what I can do now is with 2 of these, I can take something like a laser disto, so something like this, and basically put them face to face. So go to the center, and I take a reading. I point the laser dot to the same target away from me, and then I get a center-to-center distance. I enter that value inside the target distance inside of Recon-3D. And so there's other things. So for example, this one here can mount both ways. So this one can mount flat. So if you wanted to put a target that was flat and another target that was flat, you can also rest the disto up on the back end. The other one needs a little target to hit on the other target on the same side, and basically you end up with the center to center target. You have to make sure they're leveled, and the tripod allows you to sort of get them at the same height, and these are a possible solution. Again, these are all prototypes. This one's 3D printed. There's a number of things I'm working on. However, I am looking at getting these manufactured as kits through somebody else, through a third party. Okay, next. So other things that you could potentially use in the field is, well, let's talk about coatings. So I know some people that use coatings and sprays, and actually on my Click 3D playlist, I did a whole episode on these things. So you can use flour, baby powder, cornstarch, whatever. These ones are, this one here is from, these are from A-Sub. It's a pretty good product, costs a little bit of money, but it can be well worth it. It can save you a lot of time. The white one is permanent. So basically you put it on, you have to wipe it off or wash it off. The blue one is temporary. You spray it and then after like an hour or two, it disappears. And the orange one is also disappears, but it takes a lot longer to disappear. This one is probably like 4 hours or 8 hours. I don't remember the exact time right now, but basically it'll last a little bit more time. Other things that I've been working on and been thinking about. So I mentioned before that lighting is very important. And so I've noticed that if you are scanning an area that is a little bit dark with Recon-3D, there is an option when you're scanning, I should mention this, to turn on the flashlight, turn on the torch. And surprisingly, if you're just a couple of meters or 3 meters from something, that extra little bit of light, you can test it for yourself. You'll notice that when you turn it on, if it's a little bit dark, you turn it on, you can see a few extra feature points come in. And that's useful. That's kind of important. It wasn't something that I was expecting even with that little light. But this is something that's for a little bit more serious kind of situations. And it would work something like this. So I have just one of those little tripods that I have. I've got a little mount here, and I've got a couple of arms with two what are called Rugo lights. So that's these guys here. So these are made from Fox Fury, very reputable company that makes forensic lighting and different lighting solutions. And basically, you turn these on, and you can scan in a completely pitch black room with this. And I found that this is super useful. Again, this is nothing fancy. There's nothing fancy kit. You can buy hardware for this. It's all cheap and all ready to go. So you do something like that, you scan, I can shut off all the lights and get exactly what I need. I learned this early on when I did a nighttime scan. I was outdoors. Now, Recon-3D is quite robust. So if you have street lighting and you have a little bit of lighting, it will actually pick up a lot of data. But for example, if there's something is in the way and you have a dark shadow, so you've got a street light, you've got a car, and on the opposite side of the car, there's there's shadow, that area may not pick up any data. So you need to illuminate it somehow, and that would be one way to do it. Or just if you're close enough or it's bright enough, you can just use the flashlight that's on the phone. Finally, if you are scanning in the field and you're going to be there for some time, you are going to chew up your battery, okay? So if you're doing like an hour or an hour and a half of scanning, you're probably not going to have a lot of battery life left. So going into the field, it's good to have some kind of a power supply, battery bank, or something like that. So these are things that you can pick up easy online. Of course, if you have access to power, you can power it however, but something smaller than this, or even this one, you could actually just power your phone at the same time while you're scanning, and then you got plenty of time for battery or juice or whatever. But to be honest with you, because the scans are so fast, if you're doing a car and typically the areas are smaller that you're scanning, you're typically not spending more than, let's say maybe 5, 10, 15 minutes scanning. So you have plenty of battery life left. Okay, on that, what I'm going to do is, I think that's good for the accessories. I don't know if I forgot something, whatever, maybe, but I'm going to head back to my other computer, and then we're going to continue on from here. Okay, so stand by one more time. Okay, I think everybody can hear me, I hope. Yes, I think so. I think so. I think so. Let me just check that. Okay. So I'm going to continue on here. And so we've talked about all kinds of things, the technology, we've gave some examples, we've gone and we've talked about the accessories. So what I want to talk about now are scanning, actual scanning and scanning tips. So for that, let me switch slides here and let me get a quick drink here. Excuse me. Okay. So when it comes to scanning, you can break up a lot of uh, the scanning process into a number of different things. So I've broken them out into 4 different groups, and these categories for me are usually what I'm thinking of when I'm scanning. And it doesn't matter if it's with a laser scanner or photogrammetry or with Recon 3D. It doesn't matter. Here, I always think about what is the sensor that I'm using and what are the capabilities and limitations of that particular sensor. In our case, it's a little, time of flight sensor that's inside of the iPhone. But you also think about what is it that I'm scanning? What are the surface properties, the texture, the geometry of the object or the environment that I'm in? So if the object is a shiny brand new car, that's one thing. If it's a clandestine grave and there's dirt and everything, that's something else. So, you have to sort of weigh what is it that you're going to be scanning and if you have to put anything additional or to help the scan along. The other thing is the environment. So are we in a very brightly lit area? Is it going to be pitch black in a, it's a house that's burned down and everything is charcoal and black or whatever. Also rain and snow. So those are important factors too. And then there's the actual capture method, how you go about to scan that particular object. What is the motion? What is the path that you're taking? So sensor object, environment, and capture method. Those things are very, very important. And what I'll do is I'm just going to very quickly go through some of these. So when it comes to the sensor, let's take the first one, which is the sensor. The thing you have to remember about the LiDAR sensor is that it has approximately a 5-meter range. Okay, that's what they say, a 5-meter range. So when you're scanning, I've had people ask me, hey, can I put this on a drone? Well, yeah, you can, but if you're up at 400 feet or 200 feet, the sensor isn't doing anything for you. Okay, so now it's back to photogrammetry, which is exactly what you have on your drone anyway. So there's no advantage to going farther than 5 meters. You will pick up data farther than 5 meters because of the photogrammetry component. So when you're scanning something small, you'll notice that there's stuff that's farther away that's getting picked up. So keep that in mind when you're scanning. You want to be within 5 meters. My rule of thumb is, up to 4 meters, between 2 and 4 meters is usually a safe bet. Okay. The other thing is to watch the depth map on the screen. So there's a depth map on the top right, and as you're scanning, it'll move. So you'll see at this particular angle here, where I'm a little bit closer to the vehicle, I'm picking up just about everything. I've got some kind of color in here in the entire depth map. Whereas when I step back a little bit and I get a different perspective here, and it's also a little bit sunnier here, you see that I get emptiness here, which means that I'm not picking up any data out in these particular areas. Okay, so distance, how far you are, is important. Now, what about the actual object itself? Well, it helps a lot when the object has texture. Okay, so if it's a flat white wall or something like that, then it's not beneficial to the overall reconstruction. You can still do it, but it helps when the object has wallpaper or you're doing a asphalt and there's dirt and grime and like whatever else. A dirty car that's been sitting in a lot, a crime scene that's got blood and things like that. Those things actually do quite well. Okay, so in cases where you don't have random texture, you can definitely put something in there. So if you have tape or temporary markers or something that you can throw up, throw it in there. If it's not important to you, then no problem. And it doesn't have to be right in. So if you were scanning, a body or something like that, but there's nothing around it, you can put stuff around it and then, just scan the body, and the body will be just fine. But the other stuff, is just used for the scan. But things like when we talk about objects like vehicles, very dark black objects, they absorb laser light. So what it does is it reduces your range. So if I have a dark black rubbery object, something or like charcoal or something like a fire scene, you're probably not going to get a 5 meter range, or at least the return on the laser is not going to be as evident. And there's a little graphic I have down here. So here you'll see this is just this is a structured light scanner, but I think it makes the example. You'll see that on the white part of this little soccer ball, you get the laser line is actually glowing because it's reflecting back very strong. Whereas if you go on the black section, it's absorbing the laser light. And when it absorbs, it doesn't give a good return. And so sometimes what happens is you have gaps in the data. Okay, so keep that in mind. Now, you can apply coatings like we talked about. There's other things that you can do, but sometimes you are just, you're in for it because you know that there's going to be a problem with whatever it is that you're scanning. What about the environment? Well, the environment does make a difference, and bright light is good, so long as it's not high contrast. You don't want something that's like really, really dark and then really, really bright. That is not the best, but a well-lit scenario is obviously a better scenario for you. And very dark conditions are going to require additional light. And I talked about that with the little lighting kit and that sort of thing. And what I found is that you'll get areas that have a little bit of light and they collect points. But then when you get into an area that's really dark, then all of a sudden nothing shows up. So you have to illuminate it somehow. Now, fortunately, since the sensor only goes, 4 or 5 meters, well, as a result, you only have to illuminate 4 or 5 meters, and you don't need a lot of light to do that. So probably one single of those Rugo lights would probably do the job, would be fine, I think, would be enough light. An interesting thing that happened to me the other day, it was actually raining. And it wasn't just like spitting rain. It was raining pretty hard. And somebody had asked me, like, can you scan in the rain? So I tried it. And interestingly, it didn't work out. And as I was scanning, I realized why. And what's happening is that the raindrops and such were splashing on the ground. And it was pretty heavy. And I tried to scan. But what happens is those raindrops and such were causing false points. So basically it was grabbing onto raindrops and such. So I wasn't getting a really good, I wasn't picking up a lot of good feature points for tracking and things like that. So, and heavy water and stuff is going to cause a little bit of havoc onto the LiDAR as well. So, if it's spitting rain or something is wet, it's fine. But if it's really coming down where it's, getting stuff messy, big drops and things like that, or you have puddled water, probably not the best scenario. Now, what about your actual scanning technique and how you scan? So this is one where, for example, the training and things like that, I need more time to cover because there's a lot of different scenarios, and the different scenarios you have to treat differently. You have to have different things that you do. But there are a few basic rules that you can sort of abide by. So one of them is, for example, moving around the object. Since one component of the fusion is photogrammetry, if you can get around an object and do a complete loop around the object, that's a really good scanning method, okay? Loop closure and being able to do 2 or 3 passes around an object, great, absolutely fine. And in fact, that's what I'm showing here. So you have 3 images. So on one loop around the car, I start with the monopod low, and I walk around and basically get the lower half of the car. And then for the second one, I'm holding on loop 2, I'm holding it kind of upright and perpendicular. That's something I didn't talk about. So the sensor, when I showed you what the dot pattern projects on a wall, what you don't want to do is you don't want to be very oblique. You want to be perpendicular to the surface. So on the third loop on this vehicle here, you'll see that what I'm doing is I'm holding the monopod up, but I'm also tilting it down towards the roof of the car. So if it's perpendicular to the roof or to the surface that you want to scan, that gives you the best chance of getting some return. Now, it doesn't have to be perfectly perpendicular, but you want to be somewhat perpendicular. If you're too oblique, where, for example, if I'm walking with my phone like this and I'm trying to get something on the ground, I'm going to find that there's a lot of gaps and there's a lot of noise, and I'm not going to get accurate data. If I tilt it down like this a little bit and I get down to the ground, now all of a sudden I've improved my scan significantly. Also, when you're holding the phone, I've seen it where people are doing this when they're scanning. So they've had too much caffeine and they're shaking like a leaf. And so if you're causing a lot of motion blur, it's not ideal. Now, it's not detrimental. Surprisingly, it's quite robust. And I think Jared had talked about some of the intelligence that's inside the algorithm, which is pulling out the frames, which, well, maybe he didn't mention it on this one, but in our interview, he mentioned it. But they basically pull out the blurred frames, and they keep the best frames from the video for the reconstruction. However, if you can go steady, that's a better, you get more frames to choose from, and that's better for you. In terms of being far or being close, if you need to get more detail on something, you can move a little bit closer. That's no problem. But there's always a constant battle between the field of view and how much you have in view and how much texture you have versus getting very close to something and then all of a sudden losing the context or losing the texture. So, for example, on the vehicle that's here, when I'm far out and I have the doors and I got the ground, the asphalt on the ground. Now, the asphalt ground or the ground usually picks up a lot of features, and the sides of the cars not as much. But if I start walking very close to the car, all of a sudden now I'm just focusing on just a very flat textured door panel, and that doesn't help me. So sometimes being a little bit further back is helpful than being very, very close. It just depends on the situation. Also, when you scan from a variety of overlapping angles, so in the case of the vehicle, I started low, then I kind of went to a mid position, and then I went overhead. So I'm overlapping, or I'm doing different loops, but each time loop 2 is going to have overlap with loop 1, and loop 3 is going to have overlap with loop 2, and possibly even loop 1 as well. So different perspectives, covering the same areas and having overlap, very, very useful. And you want to do all that so you can get good, accurate data. And so I was going to touch on a little bit of the accuracy studies that have been done out there today. And I've had the honor of being able to peer review a number of papers that are going to be out there in the near future, and some may have been published already. But I've listed a bunch of iPhone accuracy studies here, and I'll just leave it up on the screen here for a second so that if you want to copy it, you want to look at them, you can definitely find it. So there are studies already that are out there. So people have been using this already or have been studying it and looking at, how well it performs. And there are more coming. I can tell you that for sure, having done some peer review here. And I think well, I don't want to get too deep into the woods here because there's a lot of caveats here, whatever. But let me show you something that I did a while back, and I think it tells one side of the story, but maybe not all. And so what I've got here is this is a lidar, a terrestrial lidar scan, and then the like the iPhone scan. And then what I've done is I put them together inside of Cloud Compare, and I've made a comparison. And this is something that a lot of people are doing now in their studies. They're producing these type of heat maps that show you the deviation between the points between a control like a terrestrial laser scanner and then whatever it is that you're trying to study and looking for accuracy. So you can see the different colors and the height ramps, but let me move into this a little bit closer. And I don't know how well you can see this on the screen, but maybe what I can do is I should be able to zoom in a bit. Okay, so when looking at the graph here, you'll see that there's a certain distribution in the number of points. So basically starting at 0, then it kind of ramps up and it goes down. And so the points with the greatest error are to the right, and the points with the least amount of error are to the left. So the closer to 0 they are here, then obviously the less deviation there is from the LiDAR scanner to something else. So one way to look at the overall errors, is to consider how many points fall within a certain range of error. And so if I jump into the top here, okay, you'll see that what it says here is that at this peak up here, we're at about 2 millimeters. And what it tells me is that there's about 14% of the points are within 2 millimeters of each other. And as I move forward here, it says that at a value of 1 centimeter, about 73.5% of the points are at 1 centimeter deviation. And then over here at 2 centimeters, I'm somewhere around getting close to 90%, 88.8%, okay? And then at 3 centimeters, I got about 96%, okay? More than 95% of the points are here. So basically what we're saying is the majority of points, okay, the majority of points fall between 1 and 2 centimeters of error, something like that, say about 2 centimeters. If you want to be really safe, about 3 centimeters. And looking back here, this is something that, you know, anybody can do. Cloud Compare is free. I mean, I teach courses on it and stuff, but it's one way to look at the error. It's not the complete picture though, okay? So, and it also depends on the alignment. There's a lot of little caveats here. But what's interesting is that a lot of other studies that are looking at this have similar kind of results, okay? I'm not going to say identical, but similar kind of results. So that's a good sign. And I've done some, well, some of the beta testers have done a bit of work in this particular area, and they've done some studies and they've been doing some different things. So what I would like to do here now is actually play a couple of little clips of interviews that I've done with the beta testers talking about their experiences with the Recon-3D app. So I'm going to put Mike Sorensen up here first. And Mike's been testing. He's been a beta tester for a while. So let me play this one, and he'll fill you in on what he's found.
I retired from the Vermont State Police about 3 years ago. Now do private reconstruction work for the Crash Lab in Hampton, New Hampshire. Got involved in doing a bunch of drone work, and then got into doing scans with iPhones. Did it with both Pix4D Catch and Recon-3D using my iPhone 13 Pro. Recon-3D scan is on the left, and the Pix4D scan is on the right. When I brought both of them into Cloud Compare, I put down targets right there and right there. And the distance that was supposed to be between them was 217 inches. When I measured in Pix4D in Cloud Compare, it came out to about 214. So I was about 3 inches off. So I'm looking forward to us all using Recon-3D, because it makes things, we're so busy that any extra couple of minutes helps us to be more productive. And as you can see, I'm kind of a stickler for detail. Like, I would clean all of this this artifacting off, and it would take me a little bit of time. The results that I get are fantastic.
Okay, that was from Mike. And I'm going to play one now from Mick Hardman from the Victoria Police in Melbourne, Australia. And let me see here. I'm going to get Mick's video queued up, and he did some testing. He's a beta tester as well.
My name is Mick Hardman. I'm an accident reconstructionist with Victoria Police in Melbourne, Australia. I've done probably 20 or 30 scans using Recon-3D now. Just in comparison, I've found the scans, which you can see here on the screen, are absolutely fantastic. The quality and even the accuracy has been almost a surprise in a way by the iPhone is fantastic. And these were only scans that took 6 or 7 minutes. So everything came up really well. As I said, I was pleasantly surprised by just how accurate it was. Clearly, the fusion of the camera and the Lidar scanner is giving a really great quality of color. The terrestrial laser scanners obviously are in bright sunshine. It can sometimes struggle between the bright and the dark to bring up those colors. The other thing with the app, I've found it really stable. Again, I was worried that maybe using an iPhone and dealing with point clouds, that there might be some drama with the phone slowing down or crashing. I haven't found that. And again, you can see the quality of what we've got here. So,
all right, great. Thank you, Mick. Appreciate it. And I'm going to do one more from Don Stevens. He's the last one, and he's an accident reconstructionist from Arizona. So let's get Don queued up here.
I've been a crash reconstructionist in Arizona for about 25 years. I investigate wrecks, and then I make models of the cars. I have been able to avoid owning and operating a laser scanner that entire time by advancing my ability to photo model cars. And so this technology with the iPhone has a lot of promise for me because I need to keep my inspection kit light, not have to check a scanner on an airplane, stuff like that. Last week I made about 12 models with the Recon-3D scanner and my iPhone 12 Pro that I bought used just for the purpose of that. I compared one of those models to a laser scan that was done by a different expert of the same car. And so I found that when you line it up with 3 points like you do in Cloud Compare, when you try and get the models to sync as best you can, understanding that this laser scan was made 6 months or so before my photo model was. So I had to pick really good, solid points that didn't move. And so I got about plus or minus a tenth, 0.01 feet. So 1/100th of a foot over 7 feet. So if I lined up the core of the car and then looked at the license plate, the points on the license plate were off by about 1/100th of a foot, which is pretty close to 1/8 of an inch. I've had this for about 15 years. It's hard to tell on the screen, but it's really about 3 feet wide on the side. And so I use it to calibrate cameras for PhotoModeler, and I've done so with 100 cameras or more. And so I took it and I set it in my living room and I put a steel tape across it that I trust, just a tape measure. And I carefully measured the distance between all the corners and then across the board itself, and then between your Recon-3D targets, which I just placed on the ground next to it, in order that I could use the Recon-3D targets to scale the project after I scanned it with the phone. And then I could bring that, having been scaled by your targets, into Rhino 3D, and then measure how closely the center of those dots was in the model to how close to what the steel tape told me they were. And the reason that I thought this was important is because I've been doing reconstruction long enough that we used to use a tape measure and a plumb bob to measure the crush on cars, which is one of the things I think is going to be useful in this technology for me. And we always said that if you could measure a crush depth to plus or minus a 1/4 inch, that was the most that could be expected. And so if I can get plus or minus 1/8 of an inch out of this technology, then I'm well ahead of what's been the standard of how we calculate crush energy and several other reconstruction parameters. So I think the resolution is more than enough for what I'm seeing in my work.
Okay. Yeah, thanks to those three gentlemen for their input and for testing. They continue testing and they continue to do some more work. We have a whole bunch of beta testers. Thank you to all the beta testers. I know many of you are here as well, so I appreciate all the work that you've been putting into this thing. So I want to talk about what's happening right now. So we are still in beta and we're getting very close to pushing Recon-3D out. And so this Monday, May 9th at 2 p.m. Eastern, that's going to be the date when Recon-3D should be available on the App Store. Okay, so Monday, May 9th at about 2 p.m. Eastern, you should expect to see it there. Now, just so you know, once it is there, if you just want to play with it, there is a free trial. Okay, so if you download it to your phone, it's not going to be completely unlocked. And that will allow you to scan allow you to do 10 scans, but they're short scans and they're on device only. So you will not be able to like do the cloud processing and everything else. So it's literally just, 10 scans locally on the phone, give you a feel for how it works and how it picks up, and give you a good feel for how long it takes for the on-device processing as well. But in order to unlock it, then you need to buy the subscription. So this is going to be a subscription-based product. So it's going to be a yearly fee. You pay the yearly fee, and then you get access to basically right now you can do as many scans as you like, basically. So there's no capped limit or whatever for the moment. Okay, for the moment. Now, the big question that people have been asking are, what is it going to be costing? So as an introductory price, okay, so we're launching this thing the first time, and it's going to be $299 US a subscription for the year. So I think it's a fair price, and it's an introductory price. And what that means is that the price will change. Okay, that's not the price that I'm going to be setting here. for good, but I think it's a fair price, okay, for the moment, considering that we're getting. I will say that we are working on a lot of other things in the background. I'll talk about those in a little bit. But if you buy Recon-3D, so in the first week only, and only in the first week, okay, I'm going to be including a free 4-hour training class. And so part of I think it's an important part of the whole process is going to be the training. And I've actually had more than 1 or 2 people contact me about training and the fact that there seems to be a lack of information on some of these other apps that are out there, and some of the training materials seem to be lacking. And my area is focusing on forensics, and so training, certification, that's always a big deal, and I don't think this should be any exception. I think that it's going to be important. Okay, so yeah, keep that in mind, that there is going to be a free training afterwards, after the week. Then it's not going to be included anymore. And like I said, I'm not going to fix a time right now when the price might increase on the subscription, but I can guarantee you it's not going to be at $299 forever. Now, in terms of the training that I'm going to be running, it's going to be covering a number of things. So I will be covering a lot of the technical aspects of the phone and how it works and things like that in a little bit more detail than what I've presented here, okay, on this particular webinar. I'm also going to be getting deeper into the best practices for scanning. So I only have so much time here. And like I said, there are a number of different scenarios that you might find yourself in. I can tell you right now that if you're in a forested area and you're scanning a car, they are different. Okay, you have to prepare and you have to practice as well. And that's an important part. So learning the best practices, and then learning the different types of environments that you might be in, and then choosing the optimal scan settings as well. You can't put everything at 1 millimeter and then think that you're going to get good scans and you're going to scan for 10 minutes. It's not going to work. So you have to understand a little bit about how the algorithm works and what are the best settings for the purposes of what it is you're trying to do. If you're just scanning a roadway and you want to get the general layout of the land, or you need a vehicle, or you have a small crime scene, then you adjust as necessary. Now, as with all my courses, there are assignments. Okay, and those assignments show that you can work independently and you can produce some good data, using the equipment or the software or the app or whatever it is that you have. So that's definitely going to be part of the course. And also how you validate accuracy. How can we do something like this and then be sure that you can validate it so that you can take it into court? Okay, so that's going to be important. And also certificates. So just to say that you've had training, to say that this wasn't just you messing around, but you actually did something, you learned, and you applied yourself, and you successfully completed the assignments and exercises. Then you end up with a certificate. So those are a number of different things. And also this link right here, Recon-3D, that is something that I'd like you to let me see if I can actually bring this up. I'm not sure if I can, but what I'll do is I can back out of this after. I'm going to post this link inside of the comments section, and this will be where you can go and you'll see it's basically like the sales page. You can go and there's additional information. There's going to be a bunch of tips and things like that. So if you can just head over to recon-3d.com/r3d, then you'll be able to see some things here. Okay, so make sure you get over there. Now, I want to talk about future plans, and obviously one of the future plans, aside from selling this and everything else, the goal here is to make a product that is usable, that is functional, and that people can apply in their work. And so I don't want to sugarcoat anything here, and I want to be dead honest with everybody about the quality of the scans that you're getting. So everything that you've seen here, in fact, a lot of the examples were from other people. They weren't my examples. And so I'm showing you what other people have done, not just what I've done. But there are a number of things that we're working on going forward, and one of them is going to be improvements to the reconstruction. And getting better and better. And in my conversation with Jared, there are a lot of opportunities to improve the app, but also the engine underneath by adding some different things. So for example, one of them is, you'll notice that where it said mode in the settings and it says standard, there is another mode that I would like to put in there, and that's for people who want greater detail. So when you want to get into finer and smaller areas, there would be a high detail mode. And well, I won't say much about it right now, but basically, if you had to do something smaller or you wanted finer details, there is the opportunity to do something like that. The other thing here is that validation studies are absolutely necessary. So I've already embarked on that with a couple of students, and there are some other things that I would like to look at. And if any of you are interested in doing some studies and things like that, you can always contact me and let me know. But in order to get data accepted, there needs to be general acceptance of a technology, but it also needs to have a measurable error rate. Okay, so validation studies are super important for this, for understanding, what kind of errors we can expect and what the limitations of a technology might be. I'm also looking at a Bluetooth option. So for example, if you have it on a pole, it didn't make it into this release, but basically you could click the button, the remote, and it would fire the record button, and then you'd hear an audible sound. It's really good for areas that you can't reach or that you want to hit record, and then you gotta get the pole up at a really high position. So you'd be able to start and stop the scans remotely via Bluetooth. Another thing is for data security. I know that right now we have some limitations because we're using a phone to do this incredible processing. And I'm amazed that we're getting the kind of data that we are with the on-device processing. So we're not transmitting anything over the internet. Some law enforcement agencies have some concerns about that, and I totally get it. So this is the early solution right now, that you can do some shorter scans and process them on the device. But in the future, I'm looking at an offline processing option. Something that I'd like to do is basically you would have an app that runs on your desktop. So you would plug your phone in, you transfer the data, and your gaming PC or high-powered desktop would do all the processing. And then basically it would spit out the point cloud data result back to you, and it would be completely offline. People have asked about textured meshing. That is a possibility in the future. Right now, I just want to focus on accurate point cloud data. I think that's the strong basis right now, because meshing can cause artifacts and it can cause other things right now. It does look nice, but I think if we can focus on and ensure that we get a clean point cloud, then you're in a much better position to produce a really solid textured mesh. And some more training and certification. So I talked about that already, but I think that's something that is important going forward. Okay. All right. So what I'm going to do now is I'm going to take some questions here, and let me see what people have to say. So give me just a second. I'm going to do my best. Okay, so Mike says, let me bring Mike's thing here, and I'll answer these questions. Can you go over the 1 to 5 millimeter, please? Okay, so in the settings, you have a slider that is basically your resolution. So if you slide it to 1 millimeter, it's gonna try and reconstruct a lot of the points. But this is only useful if you're close to something. And so let's say 1 meter, 3 feet away from something, maybe 2 meters, whatever. And you've got good texture, you've got a good thing, and you're going to do a short scan. So usually what I say as a rule of thumb, 1 millimeter resolution, 1 minute of scanning. That's good. That's something that you can work with. Okay. If you push it too hard, again, you're going to be waiting either an extremely long time because you can end up with a lot of data. Oh, and somebody didn't ask this, but file sizes. So a typical 2-minute scan or something would be something like, let's say, like 600 megabytes. Could be a gigabyte if you're using a little bit higher resolution. I've seen the biggest scan that I've done I think it was maybe like 2.5 gigs or something like that. So it is quite a bit of data. So so Mike, yeah, 1 millimeter. Think about 1 minute. You need to be close. 5 millimeters. You can be 3, 4, 5 meters away and still achieve the 5 millimeters. Okay, let me get back up here and turn this off. Let me see here. So Tony, is the 3D software similar or identical for the iPad Pro? It's identical. It's the same software that runs on both. So as far as I can tell, the sensor outputs the exact same pattern as I showed you in this presentation earlier, but the software itself is the same. Now, of course, the iPad does have the better chip, so it should be able to process things a little bit faster. I haven't run full comparisons, but I have run a bunch of things on my iPad, and it's, I don't know, it's marginally better. I won't say there was like a massive difference, but it was marginally better. But I have to do a better test, let's say. Daniel says, will the subscription be limited to one device, or can it be installed on more than one iPhone? Yes. So currently, if you have an iPad and an iPhone, you can take one license and install it on both. Okay, so we allow you to do it on more than one device. Okay, so if that's what you have, then you should be okay. All right. Let me see here. Mike, Apple Watch is a trigger. Okay, yeah, maybe. Okay, we'll see about that. We'll have to look at that. So this is a good question. And I think I should clarify this, and maybe somebody from EveryPoint could also chime in here. But so people ask, what's the difference between Recon-3D and EveryPoint? Can more than one scan be combined to one point cloud? So there's two questions here. Let me answer the first one. So the difference between Recon-3D and EveryPoint is that EveryPoint is a company that provides technology. So the EveryPoint app is what I would call a technology demonstrator. So it was out there to show people that these are the kinds of things that we can do. Now, I can be corrected here, but I understand that the EveryPoint app is not going to be around forever. The other difference is that I have some very specific things in the Recon-3D app, which is dedicated to forensics. And as we go forward, these little features and additional things that we put in there, and maybe some of the on-device stuff or some of the stuff that we're doing in the background may be unique to Recon-3D and not to EveryPoint. But just understand that I know that a lot of people have been saying that they have the EveryPoint app. The EveryPoint app, again, is not going to be around forever. It's a demonstrator. Okay, let me see what else that we've got here in terms of questions. Tom is asking, what's the average file size for a 5-minute scan mid-resolution? Something like that, I think you can expect about a gigabyte. It has to upload about a gigabyte. I didn't mention this before. It's one of the features, but for those of you that have limited data plans, you can choose to upload via Wi-Fi, via cellular, or both. So it'll find the best connection and do both, or none at all. You can always save it for later and wait till you get home and do it on Wi-Fi, or you can have both of them on and it will do both. So you have an option there. There is quite a bit of data, though. It does collect a lot of data. So yeah, I think a 5-minute scan, you're looking at about a gigabyte for sure. So this is an interesting one. So Charlie's is asking, recommendations on the iPad versus the iPhone for processing. So for on-device processing, in theory, the iPad is better. But I can tell you that we're throwing a lot at these mobile devices, okay, in terms of the processing. So the other thing you have to think about is not so much the processing, but the scanning. So there's a big difference when I take this and I put it on a pole and I put it up high versus just holding an iPad and trying to get an iPad up into the air. It's heavier, it's a little bit bulkier. The phone is good for interior spaces and smaller areas. So you kind of have to think about, what do you think you're going to be scanning, and are you going to be processing solely on the device, or are you going to be doing it on the cloud as well? So keep those two considerations in mind. Let's see here. Can you combine multiple scans? So that was a question I didn't answer before, but I knew I saw it here. So David had it up here as well. So right now on the device, you cannot combine multiple scans. Okay. So, but you can do it in Cloud Compare. You have enough overlap between the two scans. You can do it elsewhere. Now, in thinking about this a while ago, there is the potential for having multiple projects come together. So it's not impossible to do. And I've heard this from a few people now. So it seems like a feature that some people would find useful. So the answer is right now, no. Could it be something for the future? Yeah, possibly. Yes, files types are E57. So the E57 file format is the point cloud format. It's only one format that we're giving out. It's a standard format. It imports into just about everything. A PC Crash, 3ds Max, Ferrozone 3D. It should go into IMAP 360. It should go into Revit. It should go into just about anything. And if you have a problem with a conversion, you need it in PLY or LAS, just bring it into Cloud Compare. You can convert it absolutely. No problem at all. Okay, no problem at all. Let me see here. Yeah, somebody make a comment about the heat. So when I process on the device, it does get hot. When scanning, it does get warm. I haven't had it overheat or whatever, but granted, I'm up here in Canada, so the chances of overheating here are pretty slim. But yeah, if you're definitely in the Arizona sun or Texas heat or something like that, you could definitely have an overheat issue where it shuts down. So yeah, keep that in mind as well. Okay, so look, folks, I've been going here for quite some time, so I think I'm going to cut it here. I want to say thanks so much to everybody. I can't believe how many people hung back in here for a while. And you know, I'm looking forward to releasing this app. Joel is asking a good question as well, and that has to do with the future. And the answer to that is I've asked this question, and the answer is I believe they are, because they're putting a lot of emphasis on the augmented reality stuff, virtual reality stuff, and that was the main reason for putting the sensor inside of the iPhone to start with. It was more about augmented reality. And there's a lot of opportunity to improve the sensor going forward. And so think of that. If the sensor were to improve in resolution, in accuracy somehow, all that would benefit Recon-3D in the reconstruction for sure. Okay, a couple other questions, and then I'm gonna call. I think this will be the last one. So, how do you address digital data integrity concern, chain of custody, court aspect when using cloud to processing? So that is something that can be addressed by looking at, for example, we could potentially get CGIS compliance or whatever. To be honest with you, what I would like to do is just make a desktop app that crunches the data for you in cases where it's really, really critical. Now, that doesn't mean that I think that would be the midterm solution, and then the final solution would be to go with the full compliance to some of these chain of custody, to address these chain of custody issues, much like, you know, evidence.com, the kinds of things that Axon is doing, and that sort of thing. So I think there's plenty of opportunities here. Okay, folks, look, it's been a long 2 hours and 17 minutes. I'm sorry for keeping you here this long. I did not want to rush. So I went through it, as I feel good about it. Thanks, everyone. Look for it on Monday. And one thing that I'm going to do right now before I forget is I have to give you guys that link. So I'm gonna pop that link inside of the chat window that will take you to the website. I certainly don't want to forget that. That would not be good. So let me go back here and I'll get the link, copy it. Let me see if it'll copy here. And I'm just going to paste it. Okay, there we go. Let's see if that goes in there. Okay, I've put it in there. Hey, look, thanks everybody. I really appreciate your time. I'm looking forward to seeing you all. If you have any feedback, by all means, you know, send me an email, drop me a note or whatever. I'm more than happy to speak to you. And yeah, look forward to seeing you next time. Take care, everyone. Bye-bye.